thank you very much for the discussion. And I think it's now time for poster pitches. Do we have authors from the first paper, Negative Side Effects and AI Agents?
Hi, I'm here. Let me just share my
screen. Great.
There we go. Can everyone see that?
Yes.
Yep.
Great. Okay, I'll be talking about negative side effects and AI agent indicators in SafeLife. So what is SafeLife? Some of you may remember last year when SafeLife was sort of presented SafeAI. It's a safety benchmarking framework where it's based on Conway's Game of Life. And the idea is that there's an agent that has to build some structures while avoiding causing side effects. Because it's based on the Game of Life, it's very good for having dynamic effects and for consequences of actions to unfold over a long period of time. So what did we do? Well, we took two archetypal agents from reinforcement learning, PPO and DQN, and we explored what sort of behaviors they have for different amounts of training. We picked some metrics that we thought are somewhat useful for trying to figure out which of these metrics affect safety and the side effect score. So these are things like exploration rate, the reward received, the length of an episode. And we trained each of these agents for varying steps, 5, 10, and 30 million for each. And we were trying to see which of these metrics were related to safety and each other. Some of the highlights include the exploration rate for PPO. As this increases, as it explores more of the environment, the side effect score goes up. But this doesn't seem to hold for DQN to the same extent. There's a sort of middle ground for DQN that is least safe. We find also that they behave differently in many ways that we talk about more in the paper. And I think I'm running out of time, so I'll leave that there. But there's many more in the paper, and check out the poster as well. Thank you.
Thank you very much. May I invite the next author?
Yeah.
Great.
Okay, so my name is Ville Vakkuri, and I'm here to present work around maturity models. So it's time for AI ethics maturity model is now. So this is shared work, and in this work we are discussing what kind of maturity models should we have for making the AI safer or more trustworthy. So what are maturity models? They are widely used in software industry. They are already also research, and they are tools to measure the capability and reference the level of that the organizations have for developing specific software. For example, here software including AI components. And why should we consider maturity models when we want to develop more ethical or trustworthy or safe AI? Is that guidelines as themselves, they are not quite practical, and we need to have tools that are already in the field that could give these organizations ways to work with these issues from ad hoc, doing something when something goes wrong, to more mature way of dealing this. So what are the steps that we need for building better AI? And the question that we want to ask here, should we have a specific, for example, AI ethics maturity model, or should we have a general AI maturity model that includes safety, trustworthiness, and ethics? This is our draft. What kind of issue, for example, looking from the AI ethics point of view, should be in the maturity model? And but we are still asking, what are the steps from ad hoc solutions dealing with when something goes wrong to automated solutions? Well, so which kind of steps we need to take? And this is not work for just a single researcher or wider group. This is a call out for all of you. So we are asking you to participate in this multidisciplinary project to find out which kind of maturity model we need for this field. So come see me on the poster session and let's have a discussion. And you can also join us through the link there. Thank you.
Thank you very much for your presentation. May I invite the next speaker?
Yes, hello, can you hear me?
Yes, perfectly.
Okay, so now can you see my poster?
Yes.
Okay, so welcome everyone. My name is Ernest. The main motivation for this work is lack of processes for engineering components implemented with AI. These processes are definitely emerging, but are still poorly discussed when compared to hardware and software-based development. And they're also not extensively discussed in the context of standardization. So standardization was the main topic of two keynote speeches today. And this is also the relevant context for our work. We are working on a standard called VDE. This is a standard to develop trustworthy autonomous cognitive systems. And this is the life cycle that is provided within the standard. It looks like the life cycle of ISO 26262, but because the ISO doesn't really consider all the aspects related to AI, we are trying to extend it. And so if you want to build, for example, a standard software-based component and make it safe, you would refer to the V model from the ISO 26262, but there is nothing like that for AI. And the main challenge with AI is that there are different techniques behind AI, so deep learning, reinforcement learning. So we cannot just have one process model, such as a V model for software. Therefore, first of all, we coined a concept of AI blueprint, which is kind of like a template process that shall be refined for a specific AI technique. And then in the paper, we've introduced an example of AI blueprint for a specific technology, in this case, deep neural networks. So this is also shaped according to the V model in this case, but again, it doesn't necessarily has to be a V model. And also we provide enrichment of this DNN AI blueprint with methods and metrics, which contribute to the assurance of the trustworthiness. More about it, you can find in the paper, so description of each of the phases, activities, which has to be performed in each of these phases. So thank you very much for your attention.
Thank you, Ernest.
Thank you.
I invite the next speaker.
That should be me. Let me share my screen.
Can you share your screen, Vaclav?
Yes, yes. Just that I have two screens.
Sorry, also your voice is a little bit soft. Do you
Okay.
mind getting closer to the mic or something?
Yeah, of course. Is it better right now?
It's getting a little bit better.
Okay. I'm sharing my screen to share at least a screen for the moment. I will go try to.
We can see your screen currently, but
Okay.
it's a little bit small. Maybe you can try to speak out a bit more.
Okay. Maybe it's just.
Thank you.
Is it better here right now? Maybe take the microphone from the camera.
Yeah, it's much better.
Okay, then I'm sorry for this.
Thank you.
We cannot hear you. Can you talk now?
I'm sorry. Sorry. Yeah. Do you hear me right now?
Yeah. Just talk louder, but yeah, we can hear you.
That's unbelievable. I'm really sorry for that. I put it into. I think I have it connected. Anyway, so is it better right now?
Yes.
Okay, I'm sorry for that. So I wanted to introduce the poster of the validation of convolutional neural networks, which we call neurocriticality. As we heard before, there is a lack of, in general, transparency and metrics from functional safety point of view in neural network world. And for that, I tried to look at this problem. So in general, we looked at the single point of failure of neurons, which we defined as, let's say, masking neurons, which we set kernel weights or neural weights to 0. And we evaluate what kind of influence does it have to the model's decision confidence. For that, we evaluated or we defined neurocriticality. We changed it into the 4 different cases so that we can just define or we can check a different severity of this criticality. And then we further defined neurocritical analysis, which give us a nice overview of what kind of neuron and what kind of layer has criticality. And furthermore, we actually defined our experience to evaluate 4 different architectures, starting from the VGG16 or from the latest one, let's say, and to the ResNet and to the MobileNet and EfficientNet. And we conduct an accuracy stability for the most 100 critical neurons on the normal data set and as well on the adversary data set. So don't hesitate to ask me. I hope that in the meantime I will solve the problem with my microphone. I'm really sorry for that, and looking forward to your question in the poster session.
Thank you very much, Václav. So this is the end of this poster session. So we have a break for 1